to take a look at the beginning of chapter 3, which is going to talk about functions. There is a certain formula that we usually use when we're writing functions that are lines. So we're going to talk about that a little bit more tomorrow. But for today, I'm just going to kind of describe what a function is, both when you look at it like as a picture, and when you look at it as like maybe a table, or you just look at it as numbers. So we'll talk about what and how those are different. Like what's the difference between a relation compared to a function? All right, so let's just look at this example. I don't think you guys have anything you have to write yet on your guided notes because you already have that printed. It says just to examine the following. So it says Anne worked as a lifeguard for $7. And then it says if she worked for 1 hour, she earned $7. She worked for 2 hours, she would earn $14. And what about if she worked for 3 hours?
No.
If she makes $7 an hour. How much? Yeah, she'd make $21. Okay? And then in 4 hours, she'd make $28. So that's $7, just to be clear there, per hour. $7 per hour. So what happens in this case? If you think about like the more hours that she works, what happens to her, like her pay? Yeah?
For every hour she works, an additional $7 is added.
Yeah. So as she works more hours, her pay is going to go up. Right? And it's exactly $7 that it goes up every hour. So what I want to do is look at how we can represent this information. Instead of writing it as a sentence, I want to write it as coordinates. Okay? So each coordinate is going to have an hour amount and a money amount. Okay? So we're going to think of it kind of like that. Hours, comma, money. So if I wanted to write a coordinate like that with the first sentence, in 1 hour, she earned $7. How could I write that as a coordinate? Think about setting it up like that, and then fill in the hours and fill in the money. Yeah?
The hours would be 1, and the money side would be
7. So you could think of that first sentence as 1, comma, 7. That's a way to represent it. Okay, so the first sentence could be 1, comma, 7. How about the second sentence? In 2 hours, she makes $14. How could you write that as a coordinate? In 2 hours, she makes $14, yeah? 2, comma, 14. And we can do that for each sentence. 3, comma, 21, and 4, comma, 28. And I think that's the next thing that they want us to write down on your guided notes. So where it says S equals, and then it has this bracket symbol, that bracket symbol just means that what comes next is a list of things. In this case, it's a list of 4 coordinates. But each one of those coordinates is like a short way of representing the sentence up above. Just remember what each number stands for. The first one is hours worked, and the second one is the money she earns. And once we represent that as coordinates, then we can start to think about doing things like graphing, okay? Because that's what we use. That's what we use to graph. We use coordinates. Is there any question how we came up with any of those 4 coordinates based off the 4 sentences or 4 pieces of information right there? So those ordered pairs, okay, you want to write this part down in the blank. Those ordered pairs are called a relation. Okay, those ordered pairs, again, they're called a relation. Basically, any set of coordinates is called a relation. Any set of coordinates at all. Now, in each coordinate, how many numbers are there? 2, right? There are 2 numbers in each coordinate. So there's a name for all of, I'm going to highlight some of them in green just to show you what I'm talking about. There's this one, this one, this one, and this one. There's a name for the 1, the 2, the 3, and the 4. There's another name for the 7, the 14, the 21, and the 28. Okay, those are all the second coordinates.
So,
And I'm going to tell you.
X-axis?
Well, they're in what we call the X and the Y spot. Yep. And I'm going to tell you what the name of the X's are called, and then I'm going to tell you the name of the Y's. The what? Yep, you can use the words input and output. Those are perfect words to use. Not the words I'm going to use this time, I don't think. But those are definitely words you can use. Or maybe I even do put them after this. But the first coordinates, okay, the ones that are all highlighted in green, the 1, the 2, the 3, and the 4, those are called the domain. Which, yes, another name for that is the input. So now, let's look at our problem. I kind of already said this. But what's the domain? What are all the numbers that are highlighted in green?
The hours.
Yep, and what are they specifically in this problem? Yep.
7, 14, 21, 28.
1, 2, 3, 4.
1, 2, 3, 4. Yeah. So your domain is all the ones that are highlighted in green. So if they asked you to find the domain of that relation, it's a list of all the first numbers. The 1, the 2, the 3, and the 4. So we just write that down. Doesn't necessarily have to be in order. It's nice to put it in order. But technically, if you put 2, 3, 1, 4, that's still the domain. 4, 3, 2, 1. I'd just be looking that you list all the numbers 1, 2, 3, and 4.
Not in order.
You can put them in order, but they don't have to be to get it right. Okay, so any question on that idea? So that's called the domain. It's all the first numbers in coordinates. Now, would 5 be in the domain of this problem? No. It doesn't say she worked 5 hours. Maybe she only worked 4 hours this time. So 5 is not in the domain. How about 2.5? Is that in the domain?
Yes.
Where? No.
Well, is 2.5 listed as one of the first coordinates?
No, but you were.
No, but 2 and 3 in the middle.
So it's in the middle of them, but is it listed as one? No, if it's not listed as one, then it doesn't count in this particular case. Maybe she can't work 2.5 hours. A better example would be maybe if you were, let's say these represented like the number of nights you go on vacation and you pay for it at a hotel. If you're paying for 2 nights at a hotel, you could do that. 3 nights you could do, but you can't pay for 2.5 nights. You can't be in the middle. Right? If you don't see a number that's in the middle listed as a coordinate, then we don't write it down as being in the domain.
Oh, so technically she should wait to the 2.5 hours. So why wouldn't it be counting?
Well, if they want to know the domain, it's just what you see listed.
Oh.
Just the ones you see listed. Because technically she could work 5 hours too, but it's not listed that she worked 5 hours, so we don't know. Right? So maybe this just represents how many hours she worked Monday, Tuesday, Wednesday, and Thursday. Was there any day, Monday, Tuesday, Wednesday, or Thursday, that she worked 2.5? Exactly 2.5, no. Okay, so it's not listed as one in the domain. Now, the second coordinates, okay, those are the money. The 7, the 14, the 21, and the 28. There's a name for those. Okay, and those are called the range. Okay, and below the word range, you should see in your United Notes, output. So right above the word output, you're going to put range. And the words domain and range, those come up a lot. So when I teach things in like Algebra 2 or pre-calculus, we talk about domain and range all of the time. So it's something you'll see a lot. So for our set, can anybody tell me what the range is?
7 pictures over here.
Right, and again, it doesn't have to be in order. It's nice if you put it in order, but you wouldn't get it wrong if you did. So the range, 7, 14, 21, 28. Any question on that? So now if I asked you, is 10 in the range?
No.
No. 10 is not a number that was listed as one of the second coordinates, so no. Any question on that first part? All right, now let's take a look at a picture and see if we can identify the domain and the range in that picture. Well, when we did the domain and the range in the last problem, we didn't have a graph like that. What did we have instead? Yeah?
Maybe a couple sentences.
And what did we do with all the sentences? We turned them all into coordinates. So that might be what we want to do first here. Let's just label the coordinates of each one of those dots, and then it will be just like the last problem. Okay. And you guys have this on your guided notes. It's probably going to be a little easier to see there than on the board, maybe. But what's the coordinate of this point that I'm pointing to right here?
Negative 1, 1.
Negative 1, 1. Okay, so there's the first one. Okay, how about the coordinate of that second one?
Is 0, 0.
That's 0, 0. And the coordinate of the third one?
1, negative 1.
1, negative 1. And the coordinate of the fourth one?
2, negative 2.
2, negative 2. Now, I want to list the domain. Okay, so remember what the domain is.
You would have negative 1, 0, 1, 2.
Yeah, negative 1, 0, 1, and 2. And how did you get that?
So first the x.
Yeah, it's all the x's. Okay, so if we want to just highlight them, that one, that one, that one, and that one. That's the domain. It's all the x's. All right, how about the range? What ones do we look at for range?
0, 1, negative 2, negative 1.
So you did 0, 1, negative 2, and negative 1. Yep. That's all your y values. So all you have to do is write them down. I'm just going to I'm going to put them in order. So what's the lowest range value?
0. Negative 1. 2, 2.
Negative 2. Yeah, and then
1, 0. Negative 1, 0.
negative 1, 0, and 1. And they don't have to be in order. I just like to put them in order because then it's easier for me to find them, especially if I have a lot of points and you start getting points like this. Well, then you may have some range values that are repeated. So if it's repeated, we don't have to write it twice. Right? We only write it once. Oops. All right. How about 1.5? Is that in the domain?
No.
No. How about 3?
No.
No, it's not listed. For the range, how about 1/2? Is that in the range?
No.
No. None of those are in the range. The only way they would be in the range is if you had more dots to represent those points. Like, let's say you had so many dots that it basically looked like this. In that case, there's so many dots now, it almost looks like it's connected, and in that case it is connected. So if I asked you here, is 1/2, when x is a half, is there a dot somewhere here that is over a half now?
Yeah.
Yeah, there is now. So it makes a big difference whether you connect the dots or you just leave the dots like that. If they're connected, then you have all the values. If they're not connected, then you only have the ones that you can see, not the ones between them. And we'll talk more about that. Any question on that? All right, so that's that one. Okay, here's another one, a little bit more similar to the first one. It says give the domain and the range. And you guys have the directions, but you need to fill in the 4 coordinates that come after it. Now, this letter that they put right here, that doesn't matter. We're just calling all of these coordinates, it's a relation, because that's what a group of coordinates is. It's a relation. And I'm just calling it relation M. It's just the name of all these coordinates. Call it M, call it P, X, Q, whatever. Call it whatever you want. Okay, so let's see if we can list the domain. Okay. Anyone think they could give me the domain of that relation? Sam?
2, 0, -1.
Yep, and again, that's not in order, lowest to highest, but it technically does not have to be. Okay. 2, 0, -1, 3. And so that's the domain of the relation. How about the range? Okay, or you could also call it the, what's another word for range? Output. So if I ask you for the range of the relation or the output, it's the same thing.
-2, 0, 1, 6.
-2, 0, 1, 6. So you gave me the range and you put it in order from lowest to highest. It's perfect. Okay, do you have to put it in order though? No, you just have to list them all. In any order you want is technically fine. Okay, so that's the range. What's another word for domain? Input. Okay, so I could say input here, could say output there. It means the same thing. Okay, any question on that? All right, so any group of coordinates, that is called a relation. Now we're going to look at a special kind of relation where none of the first coordinates are the same. In all the ones we've done so far, that has been true. There were no repeats in the first coordinate. And if there are no repeats in the first coordinate, that is called a function. Okay, so on your guided notes, where it says when no first coordinates are the same, this relation is called a, you want to fill in the word, function. Okay, so a function is a special kind of relation. It's a special set of coordinates where the x value never repeats. If we look back at the ones we did, 2, 0, -1, 3. Are there any repeats in those numbers I just said? No. So this, not only is this a relation, but it's a special relation called a function. Let's look at this one. -1, 0, 1, 2. Did any of the numbers that I just said repeat?
No.
No. So this is another example of what's called a function. Okay. So next to the bullet point you have where it says in a function, after that you want to write the second coordinate can repeat or be the same. But none of the coordinates can have the same first number. Okay, so the second coordinate can be the same, but the first number cannot. So part of what we're going to do is I'm going to give you some coordinates, and I'm going to ask you, are they a function? Yes or no? If the first coordinate never repeats, it's a function. If it does repeat, then it is not a function. The second coordinate, that doesn't matter. The second coordinate can repeat, it cannot repeat. We don't even look at the second coordinate. What we're looking at is the first coordinate. And just ask yourself, does it repeat? Yes or no? Okay, does everybody have that bullet written down? All right, so we started by talking about relations, which are just a bunch of coordinates, and now we're talking about a function, which is a group of coordinates where the first number never repeats. All right, let's look at this one. So here's the relation. I'm calling this group of coordinates A. It's at the top of the second page. And this time they're asking us three things. What's the domain? What's the range? And is it a function? Right, let's start with what is the domain? The domain. Hey, anybody that could tell me what the domain is?
1, -1, 2,
Okay, so 1, yep. -1.
2,
2, okay.
-2,
-2,
3.
and 3. No, it's all the first coordinates. Can somebody else tell me the range? And remember, if a number repeats, you do not have to write it twice. Writing it once is enough. Yep.
-3, 3, 5, -3, and -1.
All right, so what do you think I should write for my final answer for the range? Like, because, was there a repeat there? Okay, so you tell me what numbers to write.
Okay, so -3,
Mhm.
3, 5, -1.
Perfect. So the range is just a list of all the numbers that you see in the second coordinate. If one of them repeats, you don't have to write it twice. Any question on that one? Right, now, the question, is it a function? What do you think? Is that a function?
Yes.
Yes, how come?
Because in the X, it doesn't repeat.
Exactly. In the X's, there are no repeats. You might be saying, well, wait, one of the Y's repeated. We had -3 repeated. That doesn't matter. We're only interested if the first number repeats. That's it. That's how you decide if something is a function or not. Any question on that one? Right, let's try another one. Okay, this is relation G. A little smaller. It only has 3 coordinates in the relation. So it says determine the domain, the range, and then tell me if it is a function. I think you guys have a spot in the guided notes. I need to make a spot. Okay, domain. Same thing with domain. If there's a number that repeats, you don't have to write it twice, just once. Okay. So what's the domain here?
6, 4, 4.
Okay, so what would you put for your domain?
6 and 4.
6 and 4. Yep. So remember, the domain is a list of all the numbers that you see in the first coordinate. If it repeats, just don't write it twice. And what about the range? Yeah, 1, 2, and 3. Yep. Okay, so now, is this a function?
No.
No, why not? There's no repeats in the range. 1, 2, 3. Right, there's a repeat in the x. 4 and 4. If there's a repeat in the x, then no. That is not a function. It's still a relation. Okay? A relation is just a group of coordinates. No rules. Just any coordinates you want. So yes, still a relation, but is it the kind of relation that's a function? No. Okay, any question on that one? So both 2a and 2b, the way I kind of gave you the problem is I just listed some coordinates. Same thing here. I listed coordinates. This time I'm going to give you a table. But you could really think of this table as being coordinates. How many coordinates am I really giving you in that table? If you were to write them that way.
4.
Yeah, I'm really giving you 4 different coordinates. What's the first coordinate that I give you in that table?
-6 and 13.
-6, 13. The top one is the x, the bottom one is the y. How about the next coordinate?
12.
-2,
Oh, that's
12. Yeah. And what about the third coordinate?
4, 10.
4, 10. And Madeline, what about the last coordinate?
5, 9.
5, 9. Hey, you don't have to rewrite it as coordinates like that. I'm just showing you that this table is exactly the same kind of problem we've been doing. They just didn't write them out as coordinates. Okay. Are they asking this time what the domain is?
No.
No. Are they asking for the range?
No.
No. They don't care about that. The only thing they want to know is it a function? So what do we have to check to see if it's a function? Do we check the x's or do we check the y's? You only need to check one of them. Yeah, you check the x's. And what do you have to check for? Yeah, if there's any repeats. And if there is a repeat, what does that mean? It's not a function. Okay. So look at the x's. Are there any repeats? No. So what does that mean? It's a function. Yeah. So it's a relation because it's 4 coordinates, but it's also the specific kind of relation that's a function because there's no repeats in the x. All right. Any questions on that? Okay, so we've seen now information given to us in a table. Another way you could see a table is like this. The only difference is this is more of a horizontal table, vertical table. That's exactly the same table as up above. They can write it vertical, or they could write it horizontal. I tend to like to make the table vertical because then it almost looks like a coordinate if you just put parentheses around it and put a comma right there. Where when you do it horizontal, it doesn't really look like a coordinate. Okay, so table. Here's another way that they can give us coordinates. Okay, this is called a mapping diagram. The ones on the left are x, and the ones on the right are y. Let's see if we can change that to coordinates and see how to make sense of it. What do you think this top one is telling me? If I were to write it as a coordinate, like this. -7, -1. Yep. Right? How about that second one? What's that one telling me? -1, 1. Now, the third one. Be a little careful with that. It's actually telling me two things. Anybody think they know one of the things that it's telling me?
4, 3.
4, 3.
And 4, 5.
And 4, 5. Yes.
It's also a repeat.
Yep. We're going to talk about that. And then what's the last one? I still have to write that down.
And 7.
Right. So this diagram on the left is exactly the same as giving you these coordinates on the right. Now this one is a problem. Whenever you have a line, two lines coming out of the same number on the left side, that means that this number is going to be used twice. It's going to be used for 3 and for 5. So that tells you whether or not we have a function, pretty much. So what do you think? Yeah?
Not be a function.
That's not a function.
Means, it means it's not on the right side, I think.
Yeah, because the number 4 is repeated.
Yeah.
Now, if you didn't have this, let's say you went like this, that would get rid of that. Would that be a function now?
Oh,
Yes.
Yeah, that would be fine. Yeah. Okay, but because we have that, it is not a function. Okay, any question on that one? Let's try one more of those mapping diagrams. I'm just going to make this one up. I just want you guys to look at this one. Let's do 1, 2, 1, 2, 3. Let's say I go like this, like that, and like that. What do you think about that one? Is that a function or not a function? Yep,
That is a function.
that is a function. Right? Because if you list the coordinates, the first one is what? 1, 1. Oops. What's the second one? Yeah?
2, 1.
2, 1. And what's the third one? 3, 2. Now you might look at it and say, well, wait a minute, you got a repeat right here. But does that repeat matter? Why doesn't that repeat matter? I thought repeats were what made it not a function.
Because it's a y.
Because it's a y that's repeating, not an x. Repeating y's, we don't care about that. That's fine. It's just repeating x's. Okay, so that is a function.
Oh, I
Okay, again, that wasn't an example on your guided notes. It's just a little bit, it's kind of similar to that one, which is why I wanted to show it. Great. Any question on that? Now, let me go back to one that we had a picture of earlier. There it is, right there. I'm going to draw something like this. Now, as I move this line, okay, when it hits a dot, all right, I want to stop. All right, so I'm going to keep moving. Have I hit anything yet?
No.
Not yet, not yet, not yet, not yet. Stop. How many dots am I hitting? 1. Okay, let's keep going. Let's keep going until we hit another dot. Okay, stop right there. How many am I hitting?
1.
Still just hitting 1.
I remember.
Keep
Open
going.
the entire paper.
How about now? How many am I hitting?
1.
Still just hitting 1. Let's keep going until we hit something else and stop there. How many am I hitting?
1.
1. Did I ever hit more than 1?
No.
No. Never hit more than 1.
I remember.
What I just did there, that's called a vertical line test. It's basically where you take a vertical line and you drag it through your graph and you ask yourself, do I ever hit more than 1 at a time? Let's say I did something like this. All right, And then you drag your line through. And you're like, okay, stop there. All right, we hit once, we're fine. Yeah, hit once, we're fine.
Error.
Now here, how many times do we hit?
2.
Twice.
Twice, that's a problem. If you hit twice, it means it's not a function. If you can drag a line through it and you only hit once, then you're good. It's a function. Okay, we're going to write that down. Okay, that's called a vertical line test, and it's most useful when you have a picture. Okay, if you don't have a picture, then it doesn't make sense to do this. Yeah.
I remember doing this last year.
The vertical line test? Yep.
Vividly.
So the vertical line test is used, and you have like a couple dashes. Under the first dash, you're going to write down used to determine if a graph is a function, okay, or basically a picture. So this kind of test is specifically used when you have a picture. And under the second bullet, it says if a vertical line only passes through, or in other words, you could say it's like hits. It only hits the graph in one spot at a time, then your graph is a function. If you draw a vertical line and you can drag it and it can hit somewhere twice, that's not good. That's not a function.
This brings so many memories from last year.
From last year?
Yeah.
Yeah. So the nice thing about the vertical line test is it doesn't really require any arithmetic or any math, or it's basically, it's more of a visual type of thing. So I have a couple pictures below this. I don't think you have these pictures on your notes. I'm just going to do them together, and we're going to see if they are a function or not. So the first thing you need to do the vertical line test is a vertical line. Now it doesn't matter what shape the graph is. You can do this test on any shape, whether it's, let's go like this. Whether you have just dots, or you have connected dots like that one, doesn't matter. Let's try it on all three of these. Okay, let's do the first one. Okay. Does it look like it's ever hitting this graph more than once as I drag it? No. No matter where I put it, it's only going to hit one time everywhere we put it. So would this graph be a function or not a function?
Function.
This one's a function. Yep. All right. Let's try it on the next one. Remember, stop once you hit something. And stop. Are we hitting more than once?
Yep.
We're hitting one.
Yeah, we're hitting exactly one time, right? I'll make it. Oh, I can't make it behind the dot. But yeah, we're only hitting it one time, so that's fine. All right, stop there. Ooh, it's close, but are we hitting more than once?
No.
Just barely. We're not. Nope. No. How about there? Nope. There? Nope. There? And there. It's close, but are we hitting more than once? Nope. And then there. Nope. So this one is also a function. Okay, let's try the last one. Okay, are we hitting more than once there? Nope. How about over here? All through here, we're good, we're good, we're good, we're good. All right, and uh-oh, how about there? Are we hitting more than once?
Yeah.
Yeah, now we're hitting twice. And if we drag it a little bit more, now we're hitting in 3 spots. That's not good. So what does that mean about this graph? That's not a function. No. So this one, not a function. So notice it doesn't say anything about it, the dots having to be connected. All right? It's just, do you hit it more than once? Now, if I did connect the dots, I don't know if that would really make a difference in this case. No, it wouldn't make a difference because I could still drag this line, and it never hits
Wait,
more than once.
So the far right.
Oh, actually, it does hit more than once right there. So now that's not a function anymore. Yeah, and you're right. I think the same thing actually happened right there.
Yeah. So would that
just
be like
barely.
undefined?
It would just be not a function now. Yeah. But when you just have the dots, it was okay. Yeah.
Quick question. I thought you said to make a difference if it were connected or not.
Right. Whether it's connected or not connected, that doesn't define whether it's a function or not. That what defines if it's a function is if it hits more than once. So like I can have dots that are a function, or if I did something like this, now I can have dots that are not a function because it hits twice.
Yeah, but when you had all the dots connected, you said that it wasn't a function, but then when they weren't connected, it was.
Yeah, so in that case, when you do connect the dots, yeah, you would change it. Yeah. But if I just said to you, I have a group of dots, is it a function or not a function? It could be either. That's what I meant. So something that's connected, like this, can be a function. Something that's connected like that can be not a function. A group of dots could be a function, or a group of dots could not be a function. So whether it's connected or not, that doesn't tell you if it's a function. Does that make sense? And whether it's just dots or not, that doesn't tell you anything either. You have to do the vertical line test.
Okay, let's go office real quick.
Yeah, is it something you need to take care of in the middle of class?
My mom, she's downstairs and she's in the office.
Okay, yeah, just saying. All right, so any questions on that idea of the vertical line test? Okay, sometimes you'll see it abbreviated VLT, vertical line test. Okay, let's try it on this one. All right, so we have 5 dots, and it says, is this a function? All right, so let's take our vertical line, draw it, and as we move it through the graph, you tell me if it ever hits the dots more than once. What do you think? Eli, what do you think? No, so that means what? Yeah, this is a function. So yes, it's a function. And Lily, can you tell me why? Like, what do we write under the explain part?
I guess there was like not another dot that was on like the same line, I guess.
So what test did we just use?
The vertical line.
Yeah, so all you'd have to do for the explain is say it passed the vertical line test.
Oh, that's way much easier.
Right? You don't have to explain the whole vertical line test every time. You don't have to say, because we drew a vertical line and it didn't hit it more than once, it means it's a function. You could just say it passed the vertical line test. So passes, and you can even abbreviate it. It passes the vertical line test. Now, if I ask you in a separate question, what is the vertical line test? Well, then you have to explain what the vertical line test is. So that's that one. Let's look at this one. So this one's a little different than the last one because the dots are connected. I know it doesn't look like dots, but think of it as like millions and millions of dots just so close together. You can't even see the dots. Okay, it makes it connected. All right, so let's take our vertical line and drag it through the graph. And the question is, does it ever hit the graph more than once? No. We're looking at that curve that goes up. Never hits it more than once. Nope. So what would we say? Function or not a function?
Function.
Yep, that's a function. And the reason why it's a function?
It passed the VLT.
Yep, passes the VLT. Now, I know that's easy to write, but make sure you know what the VLT means in case I ask you, what is the vertical line test? Okay. Okay, so again, I know a lot of space on the guided notes because there are a lot of pictures. All right, why don't you guys try example 3C? Where's example 3C? Right there. So take a second, okay, on your own, determine if it's a function or not, and then under explain, just tell me why you think what you think. All right, let's look at this one. Zach, what did you say about this one? Is this a function? Yes or no?
No.
No, I agree with you. This one is not a function. Can you tell me why?
It hits 2 lines at once.
Right. If you draw a vertical line, just putting it right there, it hits more than once. Now you might say, well, here it doesn't. Okay, but here it does. So if it can hit somewhere more than once, then it fails the vertical line test. Okay, so why is it not a function? You just put down fails the vertical line test. To pass the vertical line test, you have to only hit the function once everywhere. And that's not true. Okay, any question on that one? Now, the next one, just to kind of review what a couple symbols mean. If I do something like this on an underline, versus something like this, someone tell me what the difference is. So yeah, what's the difference?
It's greater than or equal to.
Yeah, which one means greater than or equal to here?
The close.
The close. So this is like all values greater than or equal to 3. And what about the top one?
That's just greater.
That's just greater than 3. So it's like the bottom one, you include the 3. The top one, you don't. Let's look at a picture and see what's going on. So it says to find the domain and the range. And then is it a function? All right, so the domain. What letter is connected with the domain? The X's or the Y's?
X.
Right, the X's. So in which way does the x-axis go? Left and right or up and down?
Left and right.
Right, the x-axis goes left to right. So the domain is every number that you hit left to right. Now, in this picture, do we have dots?
No.
Or is it connected?
Yeah.
It's connected. It's connected, so you could think of it as, right? It's like you have millions and millions and millions and millions of dots. There's so many that they're all connected. So we can't write the domain like we did here. Where did we do it? We can't just write it like 1, -1, 2, -2, 3, because there's millions of dots. You'd have to write like 1.01, 1.02, it's millions of numbers. So we got to write the domain a little differently.
It takes years.
Yeah, it would take forever. So let's go back, if I can get back to the diagram. There it is. Think of the domain this way. I'm going to put up like a boundary. Domain is left to right. This is the farthest left that we go. This is the farthest right that we go. Does everyone agree with that? We don't go any further left and right? The domain is everything from here to there. It's all those numbers. So what we want to do is look how far left. What's the furthest left number that we go to?
4.
-4. So that's the furthest left one. That goes on the left. What's the furthest right one that we hit? 4. And does anyone remember when we did something like this, you put the letter in the middle, and we have to put 2 inequality signs that point the same way. They point left. Right. Now, if it was a filled-in circle, we would use less than or equal to. But is that a filled-in circle? No. So we use just a less than and another less than. That's how you write the domain. This means the domain is every number that's bigger than -4, but smaller than +4. And that includes everything, like 2.5, 2.6, 0.7, 3.9. It's every number between -4 and 4. That's how you write it. So is there any question why I had to write it this way versus writing like a list of numbers with commas? Can't do the list of numbers with commas because there's too many points to write. Can't write them all. Now for range, we're going to do pretty much the same thing. What letter is connected with range? That's the Y. And does the y-axis go left and right, or does it go up and down? It goes up and down. So what we want to do now is look at the up and down. That's the range. So put like a mark there. Put another mark up here. And the range is everything that you hit up to down. So start with your lowest, and then put your highest. And then we'll fill. Okay. So what's your lowest y value that you ever hit on this graph? -3. And what's the highest that we go? Yeah, 5. Now we have to put our inequality symbols in, and they're both going to point to the. How did they point before? They pointed to the left. They always point to the left. Yeah. Now, do you actually hit -3, or do you just get close to it? Keep in mind what kind of symbol that is. So do you hit the -3, or do you just get close to it? Yeah, we just get close to it. Okay. How about the 5? Do we actually hit the 5? Like, do we include the 5, or do we not include the 5?
Yes.
So it's a filled-in circle?
No.
No. So should we include the 5 or not include it? It's the difference between, like, this or that. So when you have the open circle, do you include the 3? Or is the 3 not included in the answer? Right, what does this mean? How would you describe that?
Less, no, greater than. Less points to the right is open circle, which is greater than.
And how would you write it like as an inequality?
So points to the right.
So, well, you start with a letter, so X,
Is greater than any number.
greater than, and then the number. So does that include 3 as one of the answers to this inequality?
Yeah.
3 is greater than 3?
Oh no, it's equal to.
It's equal to. So is the number 3 included in this answer?
No.
No. When you have an open circle, think of that open circle, it's like a shield, it's protecting that number, you can't get to it. Right? When it's a filled-in circle, it's like the shield broke and then like the ink filled in the circle or something, you got to it. Okay, so you can't, the 3 is being protected, that's not part of the answer. Okay, so that means greater than 3 is an open circle. You only put the equal to symbol when it's a filled-in circle. So on this one, do we reach the number 5 or okay. So yeah, do we reach the 5 or do we not reach the 5? You only reach the 5 if it's the filled-in circle. Filled in means you reach the number. We get close to it. We don't reach it. The only way you could reach it is if it was like that. Okay, when it's an open circle, you never use the equal to symbol. When it's a filled-in circle, you do. Right? We'll try one of those. So how about this part's a little easier. Is that a function? What do you think?
Yes.
Yes, it is, because if you drag a vertical line through it, it never hits more than once. So yes, that is a function. All right, let's try. Let me try one more like that. Okay, you don't have this one on your guided notes. I'm just going to make it up. Let's take that. That like that. And let's draw a picture. Okay, something like that. Let's start with just figuring out, is this dots or is it connected? It's connected. So you're not going to be able to write a list of numbers with commas because there's too many. There's millions of them. So we're going to have to write it like we did up above. Okay. When we do the domain, what letter do we always think about with domain?
X.
X. And then what letter do we think about when we do range?
Y.
Y. Now, is the domain how far left and right you go, or how far up and down? Left and right. So what you want to do is look at the farthest left that you go, which I think is right about here, and the farthest right that you go, which in this case is right there. What's the farthest left that we go in this one? Yeah?
Negative 4.
-4. And what's the farthest right that we go? Really?
Farthest right would be 5.
Yeah, farthest right we go is 5. And both the inequality symbols have to point which way? They both point to the left. Now, this is the -4. Do we put the equal to symbol pointing to the left, or do we leave the equal to symbol off?
Maybe we take out the equal symbol.
How come?
Since one is negative, one is positive.
Don't look at anything else. Just look at that.
Oh,
That's a filled-in circle.
yeah. So it'd be equal to.
That means you put the equal to. Yes. All right. And now, on this one, does it look like we're actually hitting 5 on that graph? Yeah, we're hitting it. So that one's okay. So in that case, we use the equal to. Now let's look at the range. This is how far down we go. That's how far up we go. What does it look like the lowest that we go is?
-4.
Negative what?
4.
1, 2, 3. So the lowest is -3.
Oh, sorry. I see 4.
And what's the highest that we go?
Negative, +3.
+3. Okay, what kind of circle is at the -3?
Close.
Closed. So what kind of symbol do we put?
Equal to.
Yeah, we got to put the equal to. Yep. What kind of circle is at the +3?
Open.
Open. So what kind of symbol would we put on that one?
Greater than.
Just
Equal to.
has to point to the left.
Oh, less than.
Less than. Right, we do not put the equal to under the 3 because it's not filled in. And then, is that a function?
No.
No. Because if you draw a vertical line, it can hit more than once. So that fails the vertical line test. So that's how you have to write the domain and range when it's connected. You put the x and the y, the smaller number, the bigger number, and then both symbols pointing to the left. If it's a closed circle, we use equal to. If it's an open circle, we don't. All right, any question on that? All right, so let's look at the last one. We may have to finish it as part of the warm-up tomorrow. But this was the last page. So on your guided notes, okay, at the bottom, it says another name for the domain. Well, we already have one other name. What else does the word domain go by?
Relation.
Domain is part of a relation, but it's the input part of it. And what about the range? What was another name for that? Output. So those are other names too. Well, here's some other names. Sometimes we call the domain the independent variable and the range the dependent variable. So if you see the word domain, x, input, all the same thing. If you see range, the letter y, output, dependent, all the same thing. Just another name for it. And certain names are usually used in certain situations. All right, so let's see if we can look at this last one. So I think you guys already have that written down. Let's just make sure, is it the same equation, negative 3x plus 12? Yep, same one. Sometime I changed it. So it says this function represents the amount of fluid ounces of juice that's remaining after you take that many sips from it. So what you're basically doing is, let's say you start out with like a 20-ounce liquid, and every time you sip exactly the same amount. If it changed, it would get complicated. So we're just going to keep it simple. Each time you sip 3 ounces of liquid. So as you sip it, the amount of liquid you have left is going to go down. This formula describes how the liquid is going down. So let's see if we can identify which variable is which. It says the amount of sips you take is x. Does anybody remember which one x is? Independent or dependent? Yep. Independent. So in this case, the independent variable is the x, and we know x is the sips that you take. Now it says the amount of fluid ounces that are left is the y. What's another name for the y? That's the dependent. Yeah. So y represents the amount of, we'll call it juice remaining. That's y. It's the amount of juice left in the container. So juice remaining. So as long as you know what x and y are, the other name for them, that part's pretty easy. So x is sips, which is independent. Y is the juice you have left, and y is dependent. Okay, so just making sure we know which one is which. And now, it says that the juice that we bought, it's a 12-ounce Gatorade. Find the domain and the range. Okay, let's write that up here too. Which one is domain? Independent or dependent? Yes, that's another name for the independent. And which one is the range?
Independent.
Got you, dependent. Yep. All right, so let's write down our formula. Y equals negative 3x plus 12. Yeah, it's acting a little weird. Right, and this table is going to help us to find the domain and range. What's a possible number of sips that you could take from the Gatorade?
2.
Could take 2. What else?
Infinite.
Well, you can't take infinite because you only have so much to sip and then it's going to be empty.
12.
I want to kind of think of the smallest amount of sips you could take.
1.
Even less.
0.
0. So we're not going to like get into taking a tenth of a sip or not. You either take a full sip or you don't. So what's the smallest amount of sips you could take?
Can you dump it?
1, so
How many?
0.
0. Yeah, you don't take a sip. All right? So you take 0. And this formula is going to tell us how much juice would be left. So we have -3 times 0 plus 12. What's -3 times 0?
0.
And what's 0 plus 12?
12.
12. So if you don't take any sips at all, how much juice is left?
12.
12. That's how much you bought and you didn't drink any. All right? What's the next number of sips we could take up from 0?
1.
Yeah, we could take 1 sip. And remember, we're filling that in for x. What's -3 times 1?
-3.
And what's -3 plus 12?
Oh, 9.
9. So if you take 1 sip, how much juice is left?
9 ounces.
9 ounces. Okay, do we still have some left? We could take another sip? Okay, let's take 2 sips. So y equals -3 times 2 plus 12. What's -3 times 2?
-6.
And what's -6 plus 12?
6.
6. So if you take 2 sips, how much is left? 6 ounces. Could we take another sip? We got some left? All right, let's take a third sip. Y equals -3 times 3 plus 12. What's -3 times 3?
-9.
And then -9 plus 12? 3. So if we take 3 sips, how much is left? 3 ounces. Can we take another sip?
Yeah.
I think we can do one more. Take a fourth sip. -3 times 4 plus 12. What's -3 times 4?
Let's just drink this one.
-12. And then plus 12?
0.
0. So if you take 4 sips, how much is left?
Nothing.
Nothing. Can we take another sip? No,
Yes, no, just one here.
we're done. So those ones that I just circled in purple, what is that?
Independent.
That is your independent. I heard X, both correct. That's the domain. And what about the ones that I just circled in red? That's the dependent, that's the Y, or in this problem they called it the range. So I know we didn't write it on the line, domain and range. I just circled it. But you can't take another sip because you don't have anything left. Okay, it's empty. All right, so we got through it. I wasn't sure we were going to get through it. But we can do another one of those tomorrow, and I think there's one in the homework. So for the warm-up, we'll do another one of those.
What's the homework?
So the homework is the worksheet on section 3.1.
What's like the lesson?
What lesson was it? Let's see, do I still have it? It's lesson 14.
14.
Yes,
Oh,
lesson 14.